Bismillahirrahmanirrahim. Hello everyone, this is another SeismoStruct software tutorial. In this tutorial I want to model a complete structure. This is a previous tutorial. We have modeled a very simple structure. It's infill masonry wall structure with frame, and then we evaluate the response of that structure using pushover analysis. So we got this curve. So now here I have created a very simple model, and this model is a three-story masonry infill wall structure, and we want to model this and then evaluate the response. In case when we got the evaluation of this structure, then we will compare with the available earthquake data. In case the earthquake data or shear force is much more higher, then we have to provide some renovation or increasing the capacity of the structure. So like this we will retrofit our building. Now let's suppose this is a very typical simple structure. It has 3 bays in X, 2 in Y, and 5 meters the length of the edge span, and this is 4 meters, and we have an opening here. So we go jump, but we use this DXA file or DWG file. So I already saved this, and I'm going to jump to the SeismoStruct software, and I'm gonna call it here building modular. So for this we use building modular, and we're considering three stories, and each story typically 3 meters. And we create a project. In the project here we have DWG, so I'm gonna import the DWG, which is already saved as a plan, and the unit is meter. Okay, so this is the structure. So here you can first model first stories, or then second, or you can duplicate this one. Now the column is 400 by 400 millimeter. I'm gonna select square, and it's 400 by 400. You can select any edge you want. So I'm gonna select this edge here, here, here. The modeling is quite fast, and you can provide first the AutoCAD file and then import this here, and without any sort of modification, and then you can model like this. So we draw the column, and the second we want to add the infill walls. So mostly we use 200 and 250. In case if it's 250, because it's 400, weight is 400, so we use 200, which is 1 brick. In case you want to 2 brick, that will be 4. So it's up to you. In case if I increase the length of the brick to 400, so that will be 4. So mostly we can create some spacing, and we know that infill panel is just as a partition structure, and also some sort of self-bearing wall, and not using for any resisting system. So the resisting system is the concrete beam column or moving structure. So what we're gonna do is that 200 is accepted, and we're selecting this one, and I can select this one from here to here. So let me say one thing, that there will be some opening, or such as wall, anything. So we're considering the opening is not exist for the time being, and instead we will consider the weight of that windows or doors to the equal to same with the infill wall. So I'm going to select this one again, and selecting this one to here, and this is our opening, so we're not going to add, and here to here, and again from here to here, and this one to end, so we do not have any partition wall here because we want to create some extra spacing here, so we're not adding, so just one want to add here, and do not have any infill wall here. And next I want to add the beams. So the beam is 400 by 500 geometry, and I'm gonna select 400 by 500, and I'm gonna select this one to here. Let me select the center, and then I can select center to center here, and select here, adding more one long beam here, and adding one long beam here, and again here. Now the entire beam is added. So the next I want to create some slab, and you can select any type of slab you want. You can change the height of the slab. So here is the height of the slab is 150, which is for 15 centimeters, quite okay. And also the reinforcement is also, you can change it, but I can consider that is as a default. And also the gravity load, you can change the live load, and you can calculate it, the live load, the gravity load, the date load, the live load, and extra some snow load also you can add it. You also can here comes to here, and you can see using H giving code categories from the code. So we're not considering that, just we're adding 1.5 as a gravity load for the superimposed date load, and 2 kilonewtons for the live load using this. Now we're gonna add this slab in entire of the structure, but I should make one things, and I'm gonna add one more beam here, and then adding the slab again to this area. Now we finished the modeling, but before we go to the structural analysis part, and I'm gonna come to in a 3D, you can see the 3D model is here. So now you can see here is a 3D model. Now we want to duplicate these two other structures, and we called here this one, so copy floor. So I'm going to first floor to third floor, and again go here from third floor to last floor. So okay, now I can go back to the 3D model, and you can see it is 2, and I should go back again from second floor to third. Let me recheck it. So let me again, I should use first floor to third floor, because that is the original stories. Why it doesn't work? So we can go to here. Let me go to the third stories. Third stories also exist. So the modeling is completed. Actually, we're gonna go to the exit create project, and I'm gonna okay, and I can call it masonry building. And so now it asks me how much shear force or base force you want. So you have to provide this shear force from the earthquake parameters, and then apply to a structure. So let's suppose it is 2000 kilonewton the total shear force. So the program will distribute this entire force to the all frames, so this frame, and then convert it to the node like this. So it's converted. So that just is giving earthquake load. And now what we're gonna do is we can go to some constraint, and here we can see the program is quite enhanced and it creates rigid diaphragms for all slabs and floors, and also it creates rigid link for here is I want to answer the question between some other friend asked me in our subscriber. So he said how you connect the masonry wall. So the here, so this is the connect is actually so some of them is we can see here it's called rigid link. So rigid link is between master node, you can see column, that C is from the getting of the column, and slab node is number node 2 is infill. So that is why the connection is automatically created for the these two elements. So if you want to see the rigid, what's the rigid link, you can go to the help menu and you can see what's rigid link. So this is giving a lot of information. And also in the here in the element classes, you can come to the infill and you can see the current type of the curve type, the last element. I'm going to select this one. Here is the legend how this is connected. So here is one link, and you can see one link, two link, 1 2, each corner has 1 2 link. So this link is given with the parameter. So now everything was default, but in case you have a project, your own project, then you have to model manually this section with the proper reinforcement, everything. Now next we want to go to the applied load. That 2000 kilonewton is already distributed in the x direction to each node. You can see each node is distributed. So that was, if we distribute this, is quite difficult for us, but program is very intelligent and it can add automatically. Now in the loading file, we also considering a static pushover analysis. So this is 0. So almost 80 centimeters pushed structure. Now you can define some target displacement based on the given code. So I'm going to using this code, and you can see this code and this criteria. I'm going to accept it, okay, and I go to back to the here in an element, and in the element I want to answer one more question that one of someone asked me how you can apply this one in applied load. Here was called element load. So what I'm gonna do is you can come to here, add, select here, add, and you can select any of the element you want to apply load. So the beam is the called P14 third story. So beam means that the beam in the third story, beam 14, we want to apply some load in a direction of C, which is gravity, and it's force. So minus 2 kilonewton per meter. And we're gonna call OK, and you can exactly see that beam 14 is here. So we added this the element load here. So now you can select all the beam and you can apply it. So but we don't need this one because we already defined the gravity load on the slab. We also can apply the graphic load as well. So as a node load anything. So we finished the loading, and the connectivity is also created automatically by the program. The constraint which we need between the infill, between this is diaphragm between slab and columns, and this one is between columns and infill walls. So everything is automatically created. This is the difference. And also this boundary condition, you can see this one is this one here, boundary condition fixed and other, and also load is applied, and also the loading force for this, and we define the target. And also you can check when we give the target, the program automatically will give us for us these criteria and a frame elements. So means everything will be checking, and it calls the masonry is not exist. So here so we used the criteria called chord rotational capacity and shear capacity, so for the infill wall and other boundary elements. Now we're gonna go to processor. In the processor we want to perform the analysis. We're gonna here, and it asks me to save. So I'm gonna call tutorial. This is gonna be tutorial 2, and I save it. Now the analysis performed. So in case if there is some unconvergence or disconvergence, you can see the response. And finally, after 50 steps is completed, and it take about 9 seconds, so quite fast. We go to the post-processing to see the response of the structure. So the first is, this is a small deformation which is a structure giving when the pushover is applied. And now we want to see the target displacement. So this is the target displacement giving for that structure. So the structure comes to here and totally collapsed. So the total capacity of the structure is almost 1,500. In previously we giving a shear force of 2,000 kilonewtons. That was calculating from the available seismic earthquakes. So now the structure has 1,600 kilonewton. So that means the seismic requirement is high than the existing structure. So what we're gonna do is we want to improve that structure. So the improved way is we can add some brassing or shear wall. Even we can use some jacketing, increasing the column sections as well. So like that you can improve. Now here, giving the data, it means the life safety is already reached and the collapse prevention target is already reached. You can see here is 0.8, and we already have here. This is the life safety, so its structure is here. This point and this point is collapse prevention, so it will start to collapse because this area is the mostly the infill wall will damaged significantly, so that will taking from this. But this one is the reinforcement. So the reinforcements also will reach to the maximum or collapse prevention after this displacement. We also can go to check some other parameters, some code based check, and you can select any of these and you can evaluate the chord rotational capacity of that column or that beam, or also shear capacity. And you can see here, so that means in this step, in the first step or step 10, or we can go to the output. This one, this is the status, and this is the performance, and this is the capacity. We can come to here, the column beam, and we want to check which element is to reached to this capacity or this demand or this saturation. None of them is reached. None of them is reached, this one. And also we can check the global parameter response, and we're gonna refresh and check that column, number 1 column. So this is the response of that column. And we also can see the hysteresis curve of each column as well. So relative to the displacement or this one, selected here, and you can see the curve is like this. This is the shear, and this is the displacement rotation. So now also you can check the element action effects. So you can go to the select the this column. So this first column, and I'm gonna see the graph. This is the column. Each chord you can see the response. This is very actually developed, and there is a lot of things that you can evaluate for the convergence, everything. So this is the end of the tutorial. If you have any question, please put in the comment and I will find time to answer you. See you for the next tutorial.